Hello and welcome to this orthographic sketching manual technique, just using shape blocks. In this case we're just going to call them 3 and 4. You can see them on the sketch pad there. Again, we're going to be looking at elevations and end elevations, but we can choose which view we're going to call the elevation. In this case, I think we're going to go for that one on the left hand side. It's slightly different orientation, but it gives us more information about the object. Now the cube itself, the cuboid, is 3 high, 2 wide and 1 deep, so we're going to start by getting the proportions of that box using the gridded paper behind at the moment, but we can get rid of that as we practice a little bit more. So the initial box is 2 wide and 3 high. So turn on the page, sketching from the shoulder and just getting that idea of the parallel lines, the vertical lines for the heights, and 4 horizontal lines for the edges of those total 6 cubes, or would be cubes if they were all there. Now I think you can see we've got at least one missing from the bottom right hand corner, so we're just going to try and just lightly put some detailing in there for that corner. The next vertical side goes up the outside of the cuboid. Then we've got a slope at the top going at 45 degrees from corner to corner on a cube is 45 degrees. So sketching that one in. It then seems to drop down vertically according to 3D view and has a horizontal step on the top. Then it seems to go vertically down for 1 cube, and then it's got a 45 degree slope again at the bottom. So looking at the source, trying to work out the position and the proportion of the various parts of various shapes, we end up with something like that, which is a fairly good representation of that 3D object. Now, if we were to look at an end view of this, we'd have to think which side we're going to look at. We could choose the left or the right. In fact, we can do both. We're going to look towards the right hand side there, so we're going to shift this end elevation to the right. It's going to be 3 high, exactly the same as the elevation, so we can project the heights across, and it's going to be 1 cube deep or thick, so we can put that back vertical line in to show the back of this particular 3D object. Now the view itself won't be that interesting because we're looking straight at it, but there are some major parts. There's a definite shelf or overhang at that top area where the pencil is now, and there's a slope starting and a vertical surface ending at the second point. So let's just transfer them across. There's the overhang, there's the bottom of the slope or the top of the flat square, and we can maybe just firm in something a little bit more accurate, but again it just looks like 3 stacked squares. The second view is essential to understand that. The third view, that's going to help again. Again, it might not be the clearest, but let's see what we get on. We're going to separate the plan and the elevation rather. Give a couple of squares gap. We've got a horizontal line representing the front surface of the elevation, and 1 square further back we'll have the back surface of that 3-dimensional object. Then we've got the right hand edge, left hand edge, and looking down. If you imagine looking down on this, there's a centre line again. Now in the past we've had those as ridges. This one, hopefully we're getting the hang of this type of drawing, we suggest we've got a sloping surface on the top and a flat surface dropped down 1 square or 1 cube. So we've got the elevation, the end elevation, and the plan. You really won't understand the elevation, the end elevation of the plan without that all-important elevation drawing. If you didn't have the 3D view, could you work that out in reverse? If you had those 3 views, would you get a clear picture in your head of what that 3-dimensional object would look like? Let's try and put another end elevation in. What difference would there be in this one? Well, this the same thickness, 1 square thick, it's 3 squares high. And in this case, we're projecting across again, 1 for the end of a sloping surface and 1 for the end of a horizontal surface, the square that's missing at the top. This looks to you and I as if it's identical to the other end elevation, but from your knowledge and your understanding of this 3D form, the bottom square there is a sloping surface sloping away from 1 high to the ground level. The top square is like a step shelf. Now, as I say, without the elevation, those other views aren't giving us nearly enough information. just put a couple of marks in there, so just to get the idea, there's little X's and O's going various surfaces. You can stop, pause, rewind, zoom in, just so you get a better idea of what those views are representing. Again, don't rush this, it's done on video so that you've got a chance to take your time, stop, pause, mute this voice, I don't like my voice either, and see if you can get a better understanding. We're moving on to the next one. This is the fourth of these sketched ideas, and this time we're going to look in a completely different direction. We're going to look in the direction of that first arrow. It's not the best view for an elevation. It's the tall end, it's 3 high, and it's 2 high, and it's 1 deep left to right. So that's where the arrow's been drawn above, and there'll be a horizontal line at the top. There'll also be a horizontal line for the top of that first square and the end of the slope. So if we just firm that in, again, it's not the clearest of drawings. Maybe this wasn't the best choice for the elevation, but let's just go with it and see what we end up with here. Now, if we're going to look, there's a slope, there's a slope. Again, they look like squares. Let's look at this end elevation, to the right only this time. We'll just look at one view and see what we get. Well, definitely we're going to start off with the same height. We can project that along. And it's 1, 2, 3 squares long in this case. Let's put those in, and we can build up the basic rectangular cuboid. It's 2D, so you're just going to see a rectangle. And we can lightly sketch in the most important points, those little dividers. So we divide it into cubes so we can identify parts. So looking at the right hand side, it's going to have one bit missing. The only bit that's going to be missing is this corner up here. And it's going to be cut at 45 degrees from the top here right down to the middle on the left hand side. So that 45 should give you a fairly simple drawing. It's a clear representation of what we're going to call in this case an end elevation would look like. Slope, parallel top and bottom, parallel left and right, horizontal and vertical lines. Now, what would this, if you pause it for a second, what would this plan view look like? Where would it sit? And what shape would it be? And would there be any internal lines? So before I actually draw it, pause the video, have a think about it. Let's just see if this matches what you thought. So we're going to start off with projecting up from the elevation. It's going to be 1, 2, 3 deep, long, going back into distance. So we'll put 3 that way. We're going to have the far end, the near end, the left and the right sides. And on the top, we're going to need to put that slope in. There's a line somewhere for that slope. So this is the basic outline at the moment. That's the front, the back, the side, left and the right sides. Remember, we're looking at the top. It's a plan view. We'll have 2 squares that will be dead flat, horizontal, then a sloping one, but we won't see the slopiness, if there is such a word, in that view. All we'll see is the join between the flat top and the sloping part drawn in there. So there's the plan, the elevation, the end elevation. You can see why the elevation is maybe not the clearest in that case, but again, there's a worked example. Get yourself some paper and give it a go.